Whales are mammals that share defining traits such as breathing air, warm-blooded, give live birth, suckle their young on milk, and have hair. Whales are entirely aquatic, with specialized adaptations such as flippers and tail flukes. Whales must surface regularly to breathe, evacuating their lungs more completely than most mammals. This explosive breath is known as a blow. A major change in the evolution was the discovery that all whales, including dolphins, share a common ancestor, the Pachycetus, a four-legged land creature that is approximately 50 million years old. The Pachycetus fossils proved to be a common ancestor by having an ear bone unique to whales. In whales, it is extensively modified for directional hearing underwater. In Pachycetus, the ear region is an intermediate between that of terrestrial and fully aquatic animals.
Through the progression of time, whales evolved from the original Pachycetus into the modern-day whale we know today. In 1978, paleontologist Phil Gingerich discovered a 52-million-year-old skull in Pakistan that resembled fossils of Kratos, illustrated as a wolf-sized carnivore that lived between 60 and 37 million years ago, in the early Eocene epoch. The skull of this variation of the whale had similar characteristics with the Archaeocete, also known as the oldest known whale to date. The newly discovered bones proved to have key features that were transitional between terrestrial animals and the earliest true whales.
The first example of evidence of whale evolution was discovered by paleontologists in 1983. The Pachycetus shows the creature with a unique ear bone, proving relations to modern whales. The original ancestors established their original position of being land creatures through showing traits of having a tympanic membrane, no protection from pressure chambers, and no good underwater sound location. They also had nostrils still in the front of their heads with no blowhole, and whale-like skull crest and elongated jaws. Another discovery showing their shift in millions of years was discovered during a 1992 excavation in northern Pakistan, which found the Rhodocetus fossil to be about 40 million years old. The fossil shows it had hind legs a third smaller than those previous. While it was able to walk on land, it could only do for short periods of time, because its small leg bones couldn't support their weight. It did, however, have flexible spines and powerful tails, giving it great agility and power in water, demonstrating the shift in evolution over millions of years.
The offspring of whales are primarily a variant form of its pre-existing parents and generations. Natural selection serves as a path for whales to adapt to its environment through the progression of time as genetics are continually being passed down through reproduction. Acting as the primary mechanism for change within the whale species, natural selection allows for speciation to take place in various regions of the aquatic environment. Moreover, natural selection allows for variations in size, color, and shape over various generations.
The two separated species, baleen whales and toothed whales, are revealed to separate and form approximately 34 million years ago, as a result of adapting to their environment. On the one hand, baleen whales shifted by having bristles made of keratin instead of teeth, in order to obtain small creatures and other small invertebrates. Another example in a shift in species is the adaptation of rorqual, the largest group of baleen whales, which use their throats, which are known as plates, to open their mouth to take in food and water. Moreover, these whales have heads that take up most of their body masses. Lastly, with the variation of toothed whales, which also includes species such as beaked whales, sperm whales, killer whales, and dolphins, which reveal the development of different species as a whole within the whale community.
Enhancing our knowledge of natural selection through generations of species, evolution plays an important part in our lives, allowing us to have a deeper interpretation of the world, the shift in animal development, and evolutionary history. The knowledge obtained through evolution gives us a better understanding of the evolutionary effects in the future to come, which allows us to take major changes to our environment seriously.